All right. Now we know who I am. I'm started up. I want to welcome Robert Nirenberg. He's going to talk about using BAS to troubleshoot climate control systems. And I've been working with Robert now for, I don't know, 8 years now, 6 or 8 years, somewhere around there, through the BEST Center. He has an IT background and then also has practical HVAC contractor and controls type of work, and is now teaching in Omaha at Metropolitan Community College. He's been a great asset to the BEST Center team, and he's one of our current experts on controls. And with that, Robert, I'm going to turn it over to you.
Thank you, Ted. Welcome, everybody. I'm just going to share my screen here. So you should be seeing my presentation. Looks like we are. I'm actually going to turn my camera view off so that we can focus on the presentation, because I am going to show some slides here with some graphics that are kind of important to see. So, as Ted said, I am an instructor at Metropolitan Community College in Omaha, Nebraska. I'm part of the HVAC department, but my primary work is in building automation systems. So, and that is what we are going to talk about today, is building automation systems and using them to help us troubleshoot a climate control system. There are many different aspects to building automation systems, but one of the most complex and certainly one of the most frequently talked about here at this conference is their interactions with climate control systems. So first off, I want to talk just a little bit about some definitions here. Building automation systems is a general term. It can include anything from climate control systems to card access and security systems to lighting control systems and well beyond. And there are a number of different nomenclatures associated with this. We have seen it listed as building management systems, energy management systems, climate control systems. It is somewhat dependent on what region of the country or world you are in, and what the engineers decided to call it when they were writing up the specifications, or sometimes what the building owner wanted to call it to begin. During this presentation, I will use the term building automation system. So all building automation systems have, there are dozens of manufacturers of these systems around. Some of them very, very large, such as Siemens and Schneider Electric. Some of them more in the medium range, such as Automated Logic or KMC Controls. There are a lot of them. And then there are smaller manufacturers or starting up manufacturers that have really potentially great growth opportunities in the industry. But there are a few functions that they all share. Just to be effective systems, they have to have a few things, and that are accessible specifically to the operators. Graphics being one of the leading features. Oftentimes graphics even sell a specific control system over another. Graphics are typically a representation of a system. Very infrequently are they an exact detailed version. Alarms are a critical feature. Trend logs or historical data and some way to access them. And reports. These are all things that are common to every manufacturer's system. And these are all things that are accessible to the building operators. Reports are kind of one of those weird things. Companies use them very differently depending on the system, but they're almost always there in some form or other. Now, we're going to go through an exercise here in a moment, but coming at this from the educational standpoint, I wanted to talk just a moment about PBL. There are two different definitions for this acronym. The first is project-based learning. And this is a hands-on approach to learning, works very well for kinesthetic learners or people who learn with their hands, which is very frequently the kind of folks that we get in technical trades programs. But it is an open-ended learning practice where you give the students a project with a really open result, something like start up a business or build a building, something along those lines. Those are both very large examples, but you let them run. You give them this challenge and see what solutions they come up with. And they really control the own direction or the direction of their own learning. And you effectively stand by the side to guide them and advise them more than direct instruction. Problem-based learning is another tool, very similar to project-based learning, but a little bit more defined. This is often how we teach students in trades programs. We sit them down in front of a system that is malfunctioning. We tell them, hey, this system is malfunctioning, fix it. It's a much more defined problem, much more directed, and lends itself very, very well to teaching our trades students and other career and technical students, because it puts the tools of the trade in their hand, whatever those tools happen to be, and gets them to deal with what, from the instructor's standpoint, is a real world problem that they may run into in the whatever field they are in. There have been many studies done for both of these types of educational tools that support the effectiveness of both methods. So let's get into the scenario we're going to work on. So you are a building operator. You're fairly new to the field, maybe a month or two, maybe up to 6 months in the field. You're working for company X, whose headquarters is in St. Louis. You work on their building. It is a multi-story building that was built 5 or 6 years ago. You're not really sure, but it's fairly recent. Hasn't gone under any major retrofits, anything like that. Each floor of the building has 2 air handling units with hot water coils, chilled water coils, fresh air intake, and relief air or exhaust air. Each air handler operates as an independent unit, but feeds a number of air terminal units, somewhere, 30, 40 units per air handler. I'm sorry, 20 or so units per air handler, 30 to 40 air terminal units per floor. The air terminal units are a basic VAV box, so variable air volume, hot water reheat coils, and a control damper. There is a boiler and chiller plant in the basement of the building. Okay. And if at any point you have any questions, do please raise your hand, throw them in the Q&A, in the chat, wherever you want to do it, as we go along. There will be some interaction here in a little bit, and I hope you'll give it a shot. So the problem that was the background information. What we've run into is we've received a cold call from the CEO's assistant. They've got a big meeting going on. A bunch of the execs are in town for the company, and they're all meeting in the CEO's office, but it's getting uncomfortably cold, which is something fairly significant for this office because the CEO is one of those folks that is always wearing the full suit. So they keep it fairly cold in there to begin with. So the fact that they're getting uncomfortably cold is definitely significant. But because of this big meeting, you do not have access to the physical space. Also, to add to the challenge, you're the only one on duty at the moment. Your normal shift partner, who has a number of years of experience more than you do, is snowed in. And the boss, who you would normally turn to as for assistance, is out to lunch. So we already have one person guessing, Michael, saying, make sure the reheat is working and turn up its set point. So that is a great start to this. Let's take a look at our building control system and see what we can see. There we go. I was going to say, assuming my slide will progress. So we jump to the building control system, and this is the graphic we are presented with. This is the air terminal unit or VAV box serving the CEO's office. So let's take a look. What's happening here? We can see we've got airflow over here on our box flow. We're at 402 CFM. Our damper is about 68% open, give or take a little bit. There's always some inaccuracy in that. Our reheat valve is 100% open, and we are dumping in 70-degree air. Okay, so that's all information. It's great information, but some of it we need to be able to compare against things. James Horst asks, what is the temperature of the hot water? We'll get to that. I think there's some more data we need to see here on this page though, because we could be overflowing our box. So our effective airflow set point is 400 CFM, which matches our reheat flow set point. So probably in the right range there. So James's point could be valid. We may not have hot enough water. Let's make sure that the complaint is real. Let's look at our room temperature versus the set point. Because as Michael suggested, maybe the set point is just turned down too low. Currently, our set point is 68, and our room temperature, our space temperature, is 65.5. So it is getting a little bit cool in there. So Bradley suggests, assuming hot water temperature is normal, either a bad reheat valve actuator or linkage is loose. So addressing the problem that this actuator here that we can kind of see on the graphics is malfunctioning in some form or other, which is definitely possible, especially given that our building is 5 to 6 years old at this point. Okay. Now, as a building operator, I'm going to step back from the scenario. This is a very common style of graphic. We're seeing a rough representation of the VAV box. We've got our ductwork, we've got our damper, we've got our reheat valve. We have our sensors associated with it. And we have a huge quantity of background data talking about our occupied set points, our unoccupied set points, our airflow set points, the size of the box. Is it enabled even? Some systems provide all of this kind of data. Some systems very significantly minimize this data and only give you something like our space temperature and the effective set point, and maybe our airflow and its effective set point. It really depends on how the contractor initially set up the building and what has been set up in the past by previous operators or requested to be set up. So there is definitely some variability there. But, at this point in time, coming back into our scenario, we've got a couple of ideas where we could be. We could have too cold a hot water, or we could have a malfunctioning reheat valve. Those are our current prevailing theories. And I think they're both very valid theories, definitely could be those things. But given that we don't have access to the space right now, we can't really go and investigate this hot water valve to see if it is working or not. So we can check on some other data in the process. So we're going to come out one screen and we're going to take a look at our floor plan graphic. This is kind of a standard graphic. Some buildings have them. They've become significantly more popular in the last handful of years than they were previously. Originally, a lot of the graphics that gave you full floor plan summarizations would be more along the lines of just statistical data, just all the readings from all the VAV boxes listed as a graphical matrix or a spreadsheet type format. So what we're seeing here on this graphic, everything looks kind of okay for the most part. We've got a couple of cold zones. We may have one hot zone here. Matter of fact, I think that particular zone is definitely having some issues. But we've got a legend here at the bottom telling us what our colors mean. Everything in green is pretty much good to go. So we're not seeing big systemic issues across our building, which, what does that lead us to the conclusion of? Any thoughts? So Bradley points out that our hot water temperature is probably good. Michael also says that our air handler supply air temperature is probably in an okay state. And Jenny says that it is very likely a room-based problem, so a very localized problem, which brings us back to the conclusion that we have a hot water reheat valve actuator issue or something similar to that. So thank you. I do want to point out something. Our CEO's office is right up here in this top right corner. We know because it has this note here on the graphic, CEO, which is useful. We've got room numbers, but as a new building operator, knowing what those room numbers mean, may or may not be useful. Okay. But what do we see here with our CEO's office? There's something weird there. And Bradley points out correctly that this CEO's office is currently showing as green, which is not what it should say. It should be in a blue situation, right? Because, hey, it's below set point. You know, we're 2.5 degrees, 2.4 degrees below set point. That should not be the case. So we do apparently have a graphical issue here, which brings us to one of the challenges that we run into with a lot of building systems is that, hey, they're built by people. People make mistakes. So apparently we have an issue where we have mislinked our graphic here. Maybe this isn't actually representative of our space. So I'm going to see if I can go back. Remember, we got 65.6 degrees here. Let's see if I can go back a screen. There we go. What's our space temperature say over here? Oh, 65.6. So at least it is showing us the correct temperature. Okay, but this background field, this green, is not accurate. So we need to have somebody look at that. And Alice states that yes, absolutely does like it cool. I'm down to 5 minutes. Wow, this time went fast. So we've got to jump to our next graphic. So we're going to jump to our air handler now. Okay, and this is literally just following the path that someone would normally take looking at this. Somebody might jump to the hot water system first or to the air handler, really depends on the taste. We're going to focus on our air handler here. Okay. And air handlers, unlike our VAVs, are big, well, really VAVs are an exceptionally complex device, but air handlers are as well. And they're very large, very high profile devices. So let's take a look at what our air handler is doing. Okay. This is a very standard type air handler. We've got our supply fan, our return fan, hot water coil, chilled water coil, and our outside air and return air and relief air dampers or exhaust air, as it's stated on this graphic. Okay. want you to take a second and look at this graphic. Do you see any problems with this graphic related to, or that could be causing our room temperature issue at the CEO's office? Wayne points out a 68-degree return temperature. Seems a little bit low, right? Michael points out that our discharge temperature way below set point. James says the hot water coil is not warming the air. And so we're going to go back to Michael's point here on the far right end of the graphic, our supply air temperature. Okay. Current supply air temperature, 43 degrees Fahrenheit, dry bulb, 41 degrees wet bulb. Our set point is at 65. So we're over 20 degrees below what our set point or our discharge should be. Trace it back to our hot water coil. Our hot water valve says it's 100% open, but let's look at our mixed air temperature. The air coming in across the hot water coil, 45 degrees. So, okay, looks like we are not heating up our air effectively. So possibly getting colder. Well, Wayne, I don't think that's going to be a likely story. I think it's probably a drift issue with our sensors. Either our mixed air is reading too high, or our supply is reading too low, or a combination of the two. But James, you're right. We're only picking up heat from our supply fan. We're not picking up anything from the coil. And Brad also pointed out that our feedback on our chilled water valve says that it's 1% open, which could be exacerbating the problem. But in December, it's pretty unlikely. Robin wants to bang on the valve for the hot water coil. So I do want to jump to our hot water system graphic here real quick, just to verify that we don't have an issue here as well. And again, busy graphic, but let's point out, just looking at our boilers, we've got leaving water temperatures in the mid to upper 70s, except on one unit that's at 165. Okay, so we definitely have something worth noting. On the previous graphic, I will back up to answer Robert McNabb's question, why we have our exhaust air 84% open. Looks like we're using it to maintain building pressure. And we are at our current set point, though this purple on this set point is concerning, right? That could mean that we're in an alarm or we're overridden. So that should be evaluated. Because you're right. In the middle of winter, having an exhaust air damper 84% open, kind of concerning. Okay. I'm also going to point out on our hot water system graphic a piece of information that would be useful on our others, and that's outside air temperature is currently 22 degrees. So the fact that we've got a cold room is significant, but our hot water system does seem to be doing what it should. We've got 164 degrees coming out, 146 coming back. So our conclusions, and I know we went through this last bit a bit fast. So we have an issue with our air handler hot water valve. So obviously we have to follow up on this. So we went and we investigated. We looked at the valve because we can get to there versus the VAV, and we found that the actuator has that characteristic burned smell to it. So we have a bad actuator. So in temporary, you've disconnected the actuator and partially opened the valve so that we can get some heat into the system without hopefully overheating everything. You add a note in the logbook because you have to document these kind of changes, especially when you override things. You add a note to the logbook, add notes all around telling the boss what you did. And when the boss comes in, it's an opportunity for you to learn what the proper procedure is, where replacement parts are within the area, and what you need to do as far as notifying other departments or contractors that some additional work needs to happen. Okay. So there is some quick caveats to this. You really need to know that your system is reliable. You cannot necessarily trust the building control system unequivocally. It has to be evaluated on a regular basis. And this is a high level function. A starting operator probably isn't going to do this, but it is something that needs to be done on a system on a regular basis. And if this were a long-term or periodic issue versus a spot issue like this, you would probably want to rely on your historic data or your data logs to get into that. Some systems are better than others at presenting this data. All right. You were great for participating. Thank you for those who did. If there are any questions, I think we're really low on time, so
We're out of
just a
time.
few. But please note the challenge on this. Take a look at this presentation later. It's accessible through the auditorium because there are other issues on that air handler that I noticed as I was creating this presentation. I want you to try and find them. Let me know what you see.